Chris. How you doing today?
Good, thanks.
Good. What we're going to start with is our continuation of the information on homeostasis. We're going to delve into three things. What exactly is homeostasis? Do you know what the elements of a control system and what it makes an incubator function? And some of the keywords we're going to want to get into are receptor. Do you know what receptor is?
I don't
You
really
don't
know
remember?
what you're talking
Okay. We're going to get into a processing core, which is the center controlling, controls the logic. The effector is the end result, and we're going to discuss what homeostasis is. Do you have any questions? Anything you
Not yet. Go
get
ahead.
into? Okay, the major goals that we're going to want to get into today are going to be what's the meaning of homeostasis. We're going to eventually, at the end of this, we're going to explain what the body temperature is and how we manage it. Let me give you some examples here. Let me see, get this one here. I think this one, yeah. One example of homeostasis, and when you're drinking ice water, you know, when you're exercising real hard and you get hot, and you know why you drink water, what it does to you.
Well, I would think it cools your body down.
Right. It's when it cools it down, the amount of water that you intake, and what that does, the cool water. What else does cool water do for you, to your body?
It rehydrates you.
Exactly, it does. Okay, now I'm going to give you a couple examples here of. Now this is a picture of a lady snorkeling. Now, how would that change her body temperature when she's immersed in water? What would you see? What do you feel would change in her body? Why would her body temperature change?
Well, the cool water cools the body.
Right, exactly. And then we're going to look at another situation. Now we have a mountaineer. He's standing on Mount Rainier. Now, you know, how many feet is it? Like 14,000 feet. Mount
Yeah, I have
Rainier
no
is.
idea,
Now,
actually.
what would he find up in
Well, it's cold there, so
very cold?
the same thing as the water.
Right. Would you think the wind affect
Right.
his body
Yeah.
temperature at all? Okay. The next one I'm going to get into here. Now we're looking at. This is another slide here. This is people sunbathing on Maui Beach, where we'd love to go. Can't get there. Where would you think happens to the body temperature or homeostasis in this situation?
The opposite, it raises your body temperature.
All right. And what do you feel? Do you get thirsty? Do you know
Well,
why you
you
get thirsty?
start sweating and you get thirsty because you're expelling water from
Yeah,
your
exactly.
body.
Right. Then we get another one here. Now, people that consume alcohol, that can change your body. As you see here, it changes the blood content sugar. Can you think of anything else that alcohol does to you?
Well, it's a diuretic, so it makes you
Yeah, exactly.
have to go to the bathroom.
Yeah.
So
too
then
much.
you
And let me see what else we have. Another slide here I'd like to show you. And then the other question is long distance running. How does that affect homeostasis?
well, if you're sweating, I guess.
Sweating, right? Your
Like
elevated
any exercise.
elevated body temperature. You've got a surge in body's temperature. The decline in breathable oxygen amounts because you're exercising so hard, so you're not being able to breathe as your body's not.
You're not taking as much oxygen.
Right, you're always taking the same amount of oxygen, but since you're running, your body is trying to enhance the amount of oxygen that your body is into.
So it's using more oxygen even though you're taking the same amount?
Yes, exactly. Right.
Okay.
So that's what I was figuring. And then you also get the rise in CO2 in your body because you're exercising. You also have a decline in the O2 or moisture content of your body. Then another slide we got. So this is the definition of homeostasis. It's the tendency towards a relatively stable equilibrium between independent elements, especially as maintained by a psychological process. And what does this mean to us? Let me give you some examples here. Let me see what I find. Okay, here's one. Now, what does our body try to maintain? What temperature does it try to maintain?
98.6.
That's right. And how does it help? How does the body try to maintain its body temperature? How does it maintain it? As you see the diagram here, there's different things. Wind affects it, the environment, the radiation coming off our body. If we're in the sun or if we're in shade, makes a difference. Also, our core temperature changes. Our extremities lose more temperature than our core does. And then if you get down here now, can you list some heat losses and heat gains that we would find in a activity? Like if you walked outside, if it was cold out, what would happen?
You would start to shiver if you got too cold.
Right, which would be heat loss. Now if you dove into it's really cold out, you go in the snow and you dump into a hot tub.
Well, your body temperature would be raised.
Right, exactly. And there would just be some fill in the blanks here that I would like you to take home. Some other issues here. There's two types of behaviorals. There's psychological behavior and there's physical behavior. And the ones we can do is we can behavioral type things when we can change our body core temperatures, we can switch our clothing, consume frosty drinks. Now, what are some of the psychological things we don't have control of?
You mean like what your body does?
Right.
Like you start shivering if you're
Right,
cold,
exactly.
or
Right.
you
Right. That's
start
when you
sweating if you're
get
hot.
goosebumps. Okay, great. If you have any questions, I'll send you more homework. I think that's perfect. We can cut it up. That's beautiful. That's all I needed.
Bye. And you